Welcome to this explainer. Okay, today we are diving into something completely counterintuitive, the wild biology of overwatering. We spend so much time obsessing over our plants drying out that we totally miss a silent and frankly way more common killer hiding right beneath the soil. Together, we're going to uncover exactly why our well-intentioned attempts to save our struggling plants so often end up sealing their doom. Let's get into it.
Picture this. It's a super relatable scenario. You walk into your living room and you spot it. Your absolute favorite houseplant is wilting. Its leaves are curling inward, it's looking sad, limp, and just totally distressed. What is the overwhelming immediate instinct we all share as plant parents? We reach straight for the watering can, right? We just automatically assume that wilting means thirst, and a good long drink is exactly what it needs to perk back up. But what if I told you that instinct might be entirely wrong?
Here is the shocking twist. Your plant might not be thirsty at all. In fact, it might be actively suffocating. When you see a plant wilting, curling, or dropping its leaves, it's really just sending out a general distress signal. It's telling you its cells have lost pressure. But here's the kicker. That loss of pressure can happen because the roots are absolutely drowning in excess moisture. So watering a wilting plant that's already sitting in soggy soil, that might literally be the exact thing that finally kills it.
Section 1. The investigation, drowning roots and hypoxia.
To figure out why this happens, we need to put on our detective hats and look at what's actually going on below the surface. It all comes down to a condition called hypoxia. When we overwater, we induce a massive oxygen deficit in the soil. You see, healthy soil is packed with tiny air pores. Think of these pores as the plant's lungs. Roots need oxygen from those pores to perform cellular respiration, which is the process that gives them the energy to actually drink water and absorb nutrients. When the soil is waterlogged, those lungs fill up with water. The plant literally drowns. Without oxygen, the roots completely shut down, so the plant wilts from a lack of water up top, while its roots are hopelessly submerged down below. It is starving for water while sitting in a puddle.
And when that oxygen runs out, things collapse fast. Take a condition known as damping off, for example. Seedling stems just give up. They get soft, water-soaked, and completely cave in. This is a real-world consequence of that oxygen deficit. Overwatering breaks down the plant's natural defenses, paving a way for something way worse than just a lack of air.
Section 2. The accomplices. Enter the water molds.
By creating this swampy, oxygen-starved environment, you're basically rolling out the red carpet for some opportunistic microscopic villains. We're talking about water molds, specifically Pythium and Phytophthora. Just like the name implies, their spores are literally built to swim and spread through water. They just wait in the soil for a flood. When your soil stays soggy, especially if the pH creeps above 6.0, these molds wake right up. If it's cooler out, say 50 to 64 degrees Fahrenheit, they cause that catastrophic seedling damping off we just talked about. But in warmer conditions, between 75 and 85 degrees, they go after mature plants. They invade the compromised roots, separate the outer layer from the core, and turn healthy, firm tissue into absolute mush.
Section 3. Deciphering the confusing symptoms.
So, the battle is happening underground, but the distress signals are flashing up top. How do we tell the difference between a thirsty plant and a drowning one? Well, if it's underwatered, it's pretty obvious. The soil is dusty, the pot feels super light when you lift it, the soil pulls away from the edges, and the leaf tips get dry and brittle. But if it's overwatered, the pot will feel incredibly heavy, the soil is persistently soggy, and you'll usually spot the lower or inner leaves turning yellow. Guys, if you pick up a heavy pot with yellowing lower leaves and pour more water in, you aren't hydrating the plant. You are literally just feeding the pathogens and making the root rot worse. Simply lifting the pot to check its weight is a brilliant, totally free habit that prevents so many of these issues.
Now, here's a symptom that tricks us every single time. Leaf scorch. You see crisp, browning leaf margins and immediately assume, oh, it got baked in the sun, or it's horribly dry. Nope. Scorch is very often a direct symptom of root rot from overwatering. The leaves are crisping up not because the soil is dry, but because the suffocating, rotting roots below are dead. They simply can't transport any moisture up to the leaves anymore. It is a masterful deception.
Section 4. Inspecting the crime scene, roots don't lie.
Since the above-ground symptoms are basically lying to us, there is only one way to find the true culprit. We have to dig deeper, because roots don't lie. To really diagnose this, you need a quick forensic exam. First, be brave and gently pull the plant out of its pot. Second, do the smell test. I know it sounds gross, but if you're hit with a foul, swampy, rotting odor, that's a massive clue that fungal spores are having a party down there.
Finally, actually look at the roots. Healthy roots are firm, rigid, and usually whitish to light brown. But rotting roots, they're soft, muddy, and mushy black. If you give a root a light tug and the outer layer slides right off, leaving a stringy little core behind, you've officially caught the water molds red-handed.
Section 5. The Road to Recovery.
Discovering root rot is definitely a heart-sinking moment, but I promise all is not lost. Now that we know what's happening, we can fix it. Recovery is all about fighting the hypoxia and ruining the water mold's favorite environment. First things first, change your watering habits. Let the top third of the soil completely dry out before you even think about grabbing that watering can again. Second, always empty the drainage saucer. Don't let your plant sit in stagnant water. To fix the oxygen flow long-term, you'll want to repot using a chunkier soil mix so those crucial air pores stay open. And if rot is already there, it's time to play surgeon. Take some sterile scissors, snip away the mushy dead roots, and repot it in fresh soil. By boosting drainage and ditching the rot, you're finally letting your plant breathe again.
Which brings us to the ultimate question for all of us plant lovers. Are you killing your plants with kindness, or are you ready to let them breathe? The next time you spot a sad, wilting leaf, I hope you pause. Remember the hidden world of hypoxia, remember those lurking water molds, and don't get tricked by symptoms like scorch. Don't just reflexively reach for the water. Investigate the pot, feel the weight of the soil, and maybe even take a peek at those roots. Understanding the science of your soil is honestly the greatest kindness you can offer your plants. Thanks for hanging out with me for this explainer, and happy mindful growing.